Solving one-step equations. Let's come up with a sound foundational approach to do that that ties into good number theory and understanding of math so that we don't just get stuck at Algebra 1, but we go cruising through geometry, Algebra 2, pre-calculus. So there are other ways of showing how to solve these problems, and they work. As long as it's good mathematics, there's more than one way to solve these. I would argue that the way I'm trying to show you is in a way that's solid mathematics that builds on a solid foundation from pre-algebra all the way through algebra and beyond. So here's the deal. One of the biggest ideas, we have the left side of the equation and the right side of the equation. Do you agree that 10 is equal to 3 plus 7? Right now the left side equals the right side. So if we were to add the same number to both sides, in this case we'd get that the left side is 15 and the right side is 15. Add the same number to both sides, it keeps both sides equal. If we subtract the same number from both sides, it'll keep both sides equal. 9 is equal to 9. If we multiply both sides by the same number, like by 3, then we will find, if we do the math, that order of operations 10 times 3 is 30, this is 30. Both sides are equal. If we divide both sides by 2, we get 5 equals 5. Both sides are equal. If we decide to multiply this by the same fraction, 2/5, and we multiply this side by the same fraction, 2/5, then we put this over 1, we cross cancel like we've talked about doing before. This gives us 4. And sure enough, 3 plus 7 is 10. 2/5 of 10 is also 4. Whatever you do the same, as long as you do the same thing to both sides stay equal. Two most important numbers in all of mathematics, 0 and 1. Solving equations, it's easier than 1, 2, 3. It's as easy as 0 and 1. If you remember, the additive identity is 0. 0 plus any number just gives you the same number back. This is 11. That's 34. 1 is the multiplicative identity. This is 9. This is 457. Those are the, okay, why is 7 and negative 7 an opposite of each other? In addition, it is because 7 plus negative 7 gives you that additive identity of 0. Why is it that 1/2 and 2 are inverses under multiplication? That's what we call opposites, recall, under multiplication. Well, because if you multiply them together, it gives you 1, which is the multiplicative identity. Okay, so the goal in solving a one-step equation, we just want to get the variable by itself. We want to determine the value of 1x, not the value of 2x or x minus 3. So what we're going to be doing is we're going to say, okay, we got 2x is equal to 14. My goal is to get a 1x on the left side since the variable's on the left side. I accomplished that by dividing both sides by 2. 2x divided by 2 is 1x. 14 divided by 2 is 7. 1 times x is just x. By creating the multiplicative identity, I know that that means that I have solved for x. My answer is 7. I can always check my work by putting a 7 in for x. 2 times 7 is 14. If it's subtraction, I want to create a 0. Now, we can do it two ways. We can say I'm going to add a 7 to both sides this way, or we can say, instead of that, we could do it below and say, I'm going to add a 7 down below here, and I know that I'm doing the same thing to both sides. But negative 7 plus 7 is 0, so I have just created x plus 0, and this is 19, and that's the additive identity, so 0 plus x is just x. We have solved for x. So, the manner in which we accomplish our goal of getting the variable by itself is by using opposite operations or opposite numbers, sometimes called inverses, to create zeros and ones appropriately in order to get the variable by itself. And then doing the exact same thing to the other side of the equation so that the equation stays equal. Left side equal to the right side. So here we go. X plus 17 is equal to 45. We can show the work down below that we're subtracting 17 from the left side and 17 from the right side. Why did we do this? Now, you can't take 17 away from the x. It only combines with the like term. 17 minus 17 is 0, so you are left with x plus 0 on the left side of the equation. Oh, we created a 0. 0 plus x is just x. That's the additive identity. We got x by itself. We did subtraction to 17 from the right side because this side dictated that that's what we needed to do. We subtracted the 17 on that side to keep both sides equal. 45 minus 27 is 28, so we now know that x is 28. We can check our work by putting a 28 there. Bingo, we've got the right answer. Now here it is, x minus 9 is equal to 24. I know that if I was to think of this as never mind. If we're just going to add 9, okay? If we minus 9 and then add 9, or even if we think of this as plus a negative 9 plus 9 is 0. So it's worth talking about. But we created 0 on the left side. We know on the left side of this equation, x plus 0 is x. Now we got x by itself, but how did we do it? We added 9 to the left side. So now we have to do the exact same thing on the right side. That keeps both sides equal. So this will give us 33, so we know our final answer must be that x is 33. Check your work, 33 plus a negative 9, or 33 minus 9 in the original form, is 24. Got the right answer. All right, we got to get x by itself, so we're focused on this side. We'll deal with that guy later. 3 is attached by multiplication. To undo multiplication, we will divide by 3, the opposite operation. And 3x divided by 3 is, lo and behold, 1x. We created a 1, the multiplicative identity, which tells us on the left side of the equation, 1 times x must just be x, because 1 times anything is whatever that thing was. Whatever we do to one side, we've got to do the same thing to the other side. We divided by 3. Let's keep both sides equal. So we divide by 3 here. 21 divided by 3 is 7. There's our answer. Check it, put it back in. For x, you're going to be fine. 3 times 7 is 21. But remember, the thing is, you guys, what drives the problem solving is to focus on the side with the variable. What must we do to get x by itself, to create a 1 or a 0? Once we figure that out, then we do the exact same thing to the other side. That's good math right there. M divided by 3 is equal to 6. I'm going to tell you right now as a teacher, ask any teacher, what's the most common mistake here? Kids say, oh look, division by 3. Oh, I could divide that by 3. The answer's 2. Thanks for playing. M is being divided by 3. We have to counteract division by 3. So what do? We multiply this by 3. Put 3 over 1 or whatever, but you're going to end up with 3m divided by 3 is just 1m. By golly, there's that number 1 again. We know that we got 1m. We know what 1m is going to be equal to, and 1 times m is just m. So we have taken care of the left side of the equation. We got m by itself. Now, what do we got to do on the right side? Well, if we multiplied by 3 here to get m by itself, we have to do the exact same thing on the right-hand side. Multiply by 3. 3 times 6 is 18. Our final answer is 18. Check your work. Put an 18 right there. 18 divided by 3 is 6, the number we started with. Oh, here we go. Now, here's where different people will give different ideas as to how to solve this. I am going to argue for this whole notion of us understanding opposites, inverses, identities, all right? We want to create the number 1. Our goal is to get right to having a 1x. So if you've looked at the videos preceding this and you understand what it is that we're talking about, 3/5 is being multiplied by x and I want to create a 1. How do I make this guy become a 1? It's easy. That's the definition of what an inverse is. It's 2 numbers that multiply to give you the number 1. So we can just go right to always multiplying by the inverse of that fraction, and on this side we will create, that's going to multiply to give you 1, we will have the 1x. So on the left side of the equation, we quickly got to getting x by itself. Now the second step, what do we do to the left side, or one side of the equation? We have to do it to the other to keep things equal. We multiply by the inverse 5/3 to accomplish the 1, so we are now going to multiply the right side by the number 1. And let's change this to a fraction by dividing by, oh yeah, the most important number in all mathematics. So we got 5 times 9 is 45, divided by 3 times 1 is 3, but let's be in the habit of cross-canceling. We have a common factor of 3 and a common factor of 3. 9 divided by 3 is 3. 3 divided by 3 is 1. What did we really do? Psst, just a little PS. We really divided this fraction by the number 1, so we didn't change the value of it, we changed the way it looked. 9 divided by 3 is 3, 3 divided by the 3 is 1. That's what we really did, but we never really actually end up showing that. But you should get comfortable with cross-canceling. Now multiply straight across, we get 15 divided by that really important number, and that is equal to 15, so we are done. It may or may not be the easiest way to do the problem. I think it's pretty efficient. But I would argue that it's the strongest way to do it mathematically, anticipating that in the future we've got to be solid with our mathematics. So I would argue strongly not to multiply both sides by 5 and then divide it by 3. That's okay, it works. But I would argue for multiplying by the inverse, multiplying for the reciprocal to accomplish our goal immediately of getting 1x. All right, ooh, look at that. We put the variable term on the right side, no problem. We got to get x by itself. We get it by itself by subtracting 24 from the right side. Instead of showing minus 24 below, I'm going to this time show minus 24 on the same line. Because think of what you're doing. 24 plus x minus 24. With addition and subtraction, you can only combine like terms. I can't combine the x and that 24. They're not like terms. That's a variable term, that's a constant. But I can do 24 minus 24, or if you wish, change to the opposite operation by taking the opposite number. 24 plus a negative 24 is 0. We accomplished our goal. We appropriately got a 0. Additive identity. Anything plus 0 is that anything. So do you agree we accomplished the goal of getting the variable by itself on the right side? The last approach then, whatever we did on the right side, to get the x by itself, we do the same thing on the left side, namely, we take away the 24. 16 minus 24 is negative 8. So in the end, our answer is x equals negative 8. Good to have it to check your answer, but we're in a hurry. Here we got to get this done. Ooh, here's something different. Negative x is equal to 14. There's at least 3 different ways that we could do this. I think any of them are good or legit. You have the right to look at a negative sign as being the opposite of. So the opposite of x is 14, so it must be that x is negative 14. That's probably the quickest, most efficient way to reason through that, and you're done with it. But if we stick to what we've been doing about getting zeros and ones, a negative x is really a negative 1x. And so if we want to undo multiplication by negative 1, we could divide both sides by negative 1. But what drove us is right here. We wanted to create a 1x, and we did that by dividing by negative 1. 1 times x is just x, so this side is all taken care of. By dividing by negative 1 here, we got to divide by negative 1 there, and our answer is negative 14. By the way, the third way is to take negative x equals 14, consider it a negative 1x, and we have the right to multiply this by a negative 1. A negative times a negative is the positive 1x. Multiply this side by a negative 1 also, and you still get the negative 14. 3 different ways to get the answer there. Okay, again, we have x by itself over here. Instead of adding the 7 over here, let's just say I'm going to add the 7 here. It only combines with that constant term. That's 0. 0 plus x. We accomplished our goal. We got x by itself. We added 7 right side. Let's go add 7 on the left side. Negative 13 plus 7 is negative 6. We're done. We have our answer. Whoa, a negative fraction. Okay, let's think about what we would do here. I want to get us right to our goal of getting a 1x. So here it is. If we multiply by that reciprocal, by the reciprocal or the inverse of this, because when you multiply by an inverse, that's its opposite under multiplication, it's got to give you a 1, a positive 1 though, not a negative 1. So we're going to multiply by, flip those guys, but that's a negative, so this has to be a negative. So that a negative times a negative will give you the positive 1 that you want. So bam! Multiply by the inverse, achieve the goal. So we got x by itself. Whatever we do on the right side, do the exact same thing on the left side. Multiply this by 16. Well, let's put 16 over the most important number in the entire world. 2 and 16 we could cross cancel. They have a common factor of 2. So we're going to divide top and bottom by 2, which is really just dividing by 1. But negative 3 times 8 is a negative 24. 1 times 1 is 1. So this is going to give us a negative 24 equals x. We can always plug it in and see if it works. But there you go. If you stick to the understanding of that, you're building your algebraic understanding on a firm foundation. And as you go into the future, you're going to be able to handle math much more adeptly because you've got that foundation. Good luck.